If you're a homeschool parent trying to figure out how to give your child or teen real coding and AI skills, not just one-off classes, but a cohesive multi-year plan, this video is for you. A lot of families I talk to are doing something in tech education, but they're frustrated because it feels scattered. One course here, another class there, nothing clearly connects. And it's hard to tell whether your child is actually progressing towards something meaningful. Today, I want to walk through how to think about building a structured coding and AI pathway that actually prepares students for competitive university applications, scholarships, and a rapidly changing job market. I'll also share some sample pathways you can borrow ideas from, based on an online coding and AI academy called CodaKid. Here's the biggest issue I see in homeschool tech education. Most coding and AI options are one-offs. They're not bad classes, but they're isolated, and that creates three problems. First, no long-term progression. So beginner doesn't clearly lead to intermediate, intermediate doesn't clearly lead to advanced. Second, skills don't compound. So students repeat concepts instead of building on them. And then third, no end goal. So there's no portfolio, no specialization, no story for college applications. Another big issue? Most programs are group classes, and that works for exposure, but it's not ideal for mastery. Coding and AI require personalized feedback, pacing that adapts to the student, room to go deep when something clicks, and without that, kids plateau. So instead of asking, what coding class should we take next? A better question is, what should my child be able to do in 2, 4, or 6 years? Strong pathways usually have 4 stages: foundations, core skill tracks, advanced electives, and portfolio creation. Let me show you what that looks like in practice. So every strong pathway starts with fundamentals. This usually includes visual logic tools like Scratch and a real programming language like Python. The goal here is not learning syntax, it's building logical thinking, problem decomposition, and confidence with code. In CodaKid's case, students begin with Scratch and Python basics, which gives them a strong base before specializing. Once students understand fundamentals, the next step is directional focus. A good pathway allows students to choose a track while still learning transferable skills. Here are some example core tracks families can model after. First, game developer track, including Roblox game development, Python game development, Minecraft modding, and more. A second one is modern software engineer track, including modern Python, coding with AI, and learning how to build real programs and tools. A third one is modern web and app development track. In this one, you'll learn web development, including HTML, CSS, and JavaScript. You'll also learn app development with AI-assisted workflows. And a fourth one is AI engineer track. AI engineer track not only helps students learn prompt engineering, but helps them learn how to build with AI, including accessing ChatGPT's API to build automations and other really cool projects. The key idea here is that students go deep in one direction instead of dabbling in everything. This depth matters for university applications. After core skills are in place, students can branch into electives that require prerequisites. This is critical because it ensures skills stack properly. Examples include machine learning, AI tools and automations, Unity or Unreal game development, UEFN, which is the game creation engine behind Fortnite, advanced Java modding, advanced AI-assisted coding. This is where homeschool students often begin operating at or above undergraduate level. And finally, we have the portfolio level. And this is the stage most families overlook and the one universities care most about. So instead of just saying, I took coding classes, students can say, I built an AI product, I launched a website or app, I started a tech-enabled nonprofit, I shipped a real project with users. In programs like CodaKid's portfolio creation phase, students focus on shippable AI products, websites and apps, startups or 501c3s, personal brand narratives, and this is what turns learning into evidence. One final point that's really important. Coding and AI are not subjects you master in groups. Students progress at different speeds, they get stuck in different places, they have different interests. And that's why pathways that combine live instruction, personalized feedback, flexible pacing tend to work far better than large group classes alone. If you're homeschooling and trying to think long term, not just about the next class, but about who your child becomes over time, having a structured multi-year tech pathway makes an enormous difference. If you'd like a free coding and AI pathways guide that lays this out visually, including example tracks from beginner through portfolio, just comment guide and I'll share it. I hope this helped you think differently about tech education and planning for the future. Thanks for your time.